Hi, we're LO3 Group 2, and this is our project, a custom peripheral for SCOMP that provides brightness control over the DE10 board's LEDs. Our goal was to expand what the SCOMP programmer can do with the LEDs. Previously, the only control was binary, so on or off, but with our peripheral, you can set brightness levels to enable more dynamic and expressive visual outputs.
Here's what our peripheral does. It gives the programmer control over the LEDs. Instead of just LEDs turning on and off, you can insert a value from 0 to 1000 to change the brightness of the LEDs. 0 is fully off, and then 1000 or higher is the full brightness that the LEDs can be. This allows us to display gradients, soft fades, pulsing effects, or animations, which are very impossible to do with binary only controlled LEDs. And then the SCOMP code can update brightness in real time. So the programmer or the user could use our peripheral to create progress bars, health indicators, or just any animation they'd like.
From the SCOMP programmer's perspective, interacting with our peripheral is exactly like working with any other memory mapped I/O device. All LEDs are assigned to a register within the peripheral. To change brightness, you simply store a value from 0 to 1000 to that register using store instruction in SCOMP. This design keeps things simple and familiar for the programmer. There's no special protocol or learning curve.
As a high-level explanation, our peripheral controls 10 LEDs using pulse width modulation. By adjusting how long each LED is on and off, we can control its brightness. What makes this special is that we apply gamma correction to the brightness values using a lookup table. This means that the brightness changes appear smooth and natural to the human eye, instead of looking jumpy or uneven.
In terms of system behavior, it's fully synchronous and responds immediately to updates from SCOMP code. Now we'll demonstrate what the peripheral can do. We'll run a simple application that updates LED brightness over time, and you'll see a continuous gradient animation where the LEDs transition from bright to dim and back.
This game and peripheral showcases how users can leverage our LED controller to get creative with brightness and animation, all through SCOMP instructions. Whether it's smooth visual effects or interactive feedback, this peripheral gives the user powerful visual output tools.
Now we'll demonstrate what the peripheral can do. We'll run a simple application that updates LED brightness over time. You'll see a continuous gradient animation where the LEDs transition from bright to dim and back. All of this is controlled through the SCOMP program, writing values to our peripheral. This shows the level of dynamic control the peripheral enables. No binary flickering, just smooth, real-time brightness control. And you can see this in both the fast and the slow ombre. Now we're going to show a sample program that portrays the creative ability our peripheral gives to SCOMP programmers. Basically, the player's goal is to raise switch 3 exactly when LEDs are at their lowest brightness. If they time it right, their score increases and it's shown on the hex display. Obviously, this gets higher on faster difficulty modes. It's basically a response time game. Once the player reaches a high enough score, they will win, and the hex display will show 777.
Thank you for watching, Kevin.
We're excited to see what SCOMP users create with our peripheral. Thank you.
Thank you, bye.
Okay, that was good.
Like, comment, subscribe.
Share, please.
Bye. Okay. How do I turn this off?